What is the main hierarchy that orders life? What is the main issue that any current blockchain technology has? What is the hierarchy that must be demonstrated first in any court of law? All of these questions have the same answer: time. The hierarchy of time passing, which is the dependency of one moment on all previous moments. All events are ordered in time in a very precise manner, and today humans can measure time distances as small as a zeptosecond. Life is created and ordered by the passing of time. The justice system must try to order events by time for a correct understanding of a case. Current blockchains do not have precise time ordering, and this is why an entire domain of engineering has appeared that uses this flaw to extract money and scam users. It's called MEV, Minor Extractable Value. Proving time ordering is an antidote for corruption. But how? Cryptographic ticks are time-ordered computations. Each tick depends on the previous tick, and ticks are produced in a continuous process. They act as an echelon of computation, and they are proof of work for the machine that produces them. They are also proof of time passing for that machine. And due to the nature of continuous computation, they ensure process hygiene. You are sure that nothing else is computed on that machine's CPU. They can also be used to construct proofs, for example, a proof of time for an event. The cryptographic tick uses a branchless algorithm to ensure homogeneity of computation and takes 100% of compute from at least one core. It uses cryptographic proofs to demonstrate execution, and it accepts a wide range of initial conditions. It defines one time unit as computation, and that time unit can be a day or an hour or a minute or a second, a millisecond. And a cryptographic tick is atomic. All ticks are alike in substance and are atomic, just like matter is atomic. Each tick is identifiable, and all proofs about the real world are reducible to proofs of time ordering. Time is radiative. Information and energy has the tendency to disperse, and as a system goes forward in time, entropy increases. But we define consensual time as structured time, agreed upon time that reduces entropy. And now, instead of time through information and energy radiating and spreading, each node that computes cryptographic ticks can reach consensus with other nodes computing cryptographic ticks until time converges into an agreed-upon accumulated master slot. Information converges and is stored by each node. So we are ready to extract the consensual information that is part of time from the radiated information that is also part of time. But this radiated information is eventually lost, and the consensual information is stored. These cryptographic ticks can be at different levels of magnitude. Some nodes will operate at second level, others at nanoseconds, and others at an hour. These ticks and subticks are implemented as cycles of compute, and the different levels of magnitude eventually converge towards the accumulated master slot. Besides time, this type of blockchain for time will also receive user data. These are events that need to be timestamped and ordered, and this is the main entropy source for the chain. We will discuss how the cryptographic ticks protocol operates in more detail in future videos, but for now the overall process has these steps: ingesting the inputs and settings, then starting the sub-cycle, which can be local or remote, ending the sub-cycles, composing the output, and presenting the output. The inputs of the process are the entropy slot, which depends on the accumulated master slot, which depends on the user-provided data, along with the time-related computation. The next timestamp is also an input and the previous tick's output. Outputs of this process are the output slot and the count of cycles for each machine. This is the philosophy behind the cryptographic tick, and in future videos you will see implementation demos.